Have you ever pondered the consequences of venturing into space without a spacesuit? Space, the final frontier, a vast expanse of nothingness, dotted with celestial bodies and galaxies. It's a realm that's piqued human curiosity and ambition for centuries. Yet it's not a place we can simply stroll into. You see, space is not designed for human survival. It's a harsh, unforgiving environment, far removed from the comfortable confines of our planet. The temperatures are extreme, swinging wildly between scorching and freezing. Oxygen, the very essence of life, is non-existent. And then there's the vacuum state, a condition that our bodies aren't designed to withstand. Spacesuits, then, are not just fancy astronaut attire. They are vital, life-preserving cocoons, engineered to buffer us against these harsh realities. Without them, we'd be like fish out of water, quite literally. So, what exactly occurs when these harsh conditions meet the human body unprotected? Imagine standing in a place that is absolutely empty, a vacuum. That is what space is like. It's a world devoid of air and matter, a literal blank canvas. And while this emptiness might sound serene, it's anything but for the human body. The vacuum of space is a harsh and unforgiving environment that our bodies are simply not equipped to handle. Without the protective shell of a spaceship or spacesuit, this vacuum can have some truly horrifying effects. When we talk about a vacuum, we're referring to a space that is entirely devoid of matter, including air. Earth's atmosphere, on the other hand, is filled with air and exerts pressure on our bodies. In space, there's no air, and consequently, no pressure. This sudden change in pressure can have some dire consequences. The absence of external pressure could cause the fluids in your body to start boiling at normal body temperature, a process called ebullition. And no, it's not the kind of boiling you're thinking of. We're talking about a spontaneous and vigorous bubbling of body fluids leading to swelling and potentially fatal tissue damage. Then there's decompression sickness, often known as the bends. On Earth, we're used to living under the weight of an entire atmosphere. In space, with the sudden drop in pressure, nitrogen dissolved in your blood could form dangerous bubbles, a condition that could lead to joint pain, a skin rash, and even paralysis. The vacuum of space is not just empty, it's a realm of extremes. The lack of air means there's no medium to carry heat away from the body, which can lead to potential overheating. The vacuum of space is indeed a hostile environment for the human body, but that's not all. In the next scene, we'll explore the temperature extremes in space and how they pose yet another challenge to human survival. So hold on to your seats as we continue our journey into the depths of the cosmos. In space, the temperature isn't just cold, it's extremely cold. And when in direct sunlight, it's extremely hot. This stark contrast in temperature is one of the most formidable challenges for any unprotected being in space. Let's start with the cold. In the shadow of a planet or moon, temperatures can plummet to -275 degrees Fahrenheit or colder. That's colder than any winter on Earth, and it's a cold so intense that it would freeze your body tissues almost instantly. Hypothermia, or the rapid loss of body heat, would set in within seconds, slowing down your heart and brain function. Your body would be unable to maintain its core temperature, leading to a complete shutdown of bodily functions. But let's not forget about the heat. When in direct sunlight, temperatures in space can soar to over 250 degrees Fahrenheit. This extreme heat would lead to hyperthermia, the opposite of hypothermia. Your body would start to overheat, causing cells to break down and organs to fail. This could potentially happen within minutes, making it just as deadly, if not more so, than the extreme cold. These temperature extremes are a result of the lack of atmosphere in space. On Earth, our atmosphere acts as a buffer, absorbing and distributing the sun's heat more evenly. But in space, without this atmospheric shield, you're directly exposed to the sun's intense heat on one side and the absolute cold of space on the other. This extreme thermal environment would make it impossible for an unprotected human body to survive. Even the most sophisticated spacesuits are designed with complex temperature control systems to protect astronauts from these harsh conditions. Temperature extremes are yet another challenge for the unprotected body in space, but there's still more. In our next segment, we'll delve into another critical issue for humans in space, the oxygen dilemma. So stay tuned as we continue our journey through the unforgiving conditions of outer space. Without oxygen, life as we know it ceases to exist. In space, this essential element is absent. This is a fact that makes the prospect of human survival in the vacuum of space a challenge of monumental proportions. Oxygen, as we all know, is the breath of life. It's the gas that we inhale in every moment of our existence, the fuel that powers our cells, and the catalyst that allows us to burn food for energy. It's such an integral part of our lives that we often take it for granted. But what happens when this life-giving gas is suddenly not available? What happens when we are thrust into an environment where oxygen simply doesn't exist? Let's delve into this a bit further. When the human body is deprived of oxygen, a condition known as hypoxia sets in. This can lead to a series of devastating effects. Initially, a person may experience shortness of breath, rapid heartbeat, and a change in color of the skin to a bluish hue. This is the body's way of signaling that it is not receiving enough oxygen. As hypoxia progresses, cognitive functions start to deteriorate. A person may become confused, disoriented, and eventually lose consciousness. If oxygen deprivation continues, the final result is, unfortunately, death. In the vast expanse of space, where there's no oxygen to breathe, these effects would be swift and severe. Even if we could somehow bypass the vacuum and the extreme temperatures, the lack of oxygen would still pose a formidable and indeed insurmountable hurdle. Yet the human spirit is indomitable. We've engineered ways to carry our own supply of oxygen into space. Astronauts breathe a mixture of oxygen and nitrogen, just like here on Earth. This allows them to survive and function in an environment that would otherwise be completely inhospitable. Without oxygen, survival in space is impossible, but that's not the end of the story. The story of humanity's journey into space is one of ingenuity, perseverance, and an unyielding desire to explore the unknown. And although the challenges are great, so too are our efforts to overcome them. Apart from the vacuum, extreme temperatures, and lack of oxygen, space also presents other threats such as cosmic radiation and microgravity. Cosmic radiation, unlike the regular radiation we're accustomed to on Earth, is composed of high-energy particles that can penetrate deep into the body, potentially causing serious health issues. These issues range from acute radiation sickness to longer-term problems like cancer. Now let's talk about microgravity. In the void of space, the force of gravity is much weaker. This lack of gravitational pull means our bodies, built for life on Earth, start to lose muscle and bone mass. Astronauts have reported up to a 20% decrease in muscle mass after just a few weeks in space, which is why they follow rigorous exercise routines even while off-planet. So, the harshness of space extends beyond what we can immediately perceive. It's not just about the lack of air to breathe or the extreme temperatures, but also about the unseen dangers lurking around every corner. So it's clear that space is not a friendly environment for the unprotected human body. We've journeyed through the harsh realities of space, starting with the vacuum state that would cause rapid decompression in the body, leading to some pretty unpleasant scenarios. We then delved into the extreme temperatures of space, where one could either freeze in the shadowed areas or get cooked in the direct sunlight. This temperature roller coaster is something that our bodies are not designed to handle. Next, we tackled the oxygen dilemma. Without our precious atmosphere, there's no oxygen to breathe, which would lead to unconsciousness within 15 seconds. Then, we addressed the threats of cosmic radiation and microgravity. The former could cause serious damage to our cells, while the latter could lead to muscle atrophy and weakened bones. While the thought of floating around in space without a spacesuit may seem thrilling, the reality is far from pleasant. It's a stark reminder of how life as we know it is intricately tied to the conditions on our home planet.